First, you can see the cockpit because smart cockpit is widely used in China, including a lot of companies. And general AI for cockpit, I think it's very important because it will redefine the HMI. I think because it has 4 generations for the cockpit. I think the first time is press button. You know, the old cars, you need a button to control the features. Okay, the next is the touch screen. Android is coming. It's going to my car. It makes the car smarter and smarter. But later, it's voice control. You can use the voice to control the cockpit. And just like NLP model, yeah, it's a voice model. But now, cockpit is copilot, you see. And you will have a copilot in your car by general AI. It's multimodal, complex controlling, understand you, and keep learning. The copilot will keep learning your style, and will be smarter and smarter. So it's totally different. So let's see something different. General AI-based assistant is a copilot. So the general AI, first, general AI could not be used as a copilot directly, yes, because it has no domain knowledge. Just like ChatGPT or Kimi in China is very widely used now, but they have general knowledge, but they don't have domain knowledge, just like car knowledge. They don't know which car is which version. So, and it has a problem that low accuracy to answer the domain question. For example, you ask your car, do you know BMW? Do you know BMW M5? M5 features. Maybe the general AI will not answer it because he don't know the latest version of the BMW. He will answer you should to check the data set and by the website. So if you have general AI, first you need to use prompting or fine-tuning. This is widely used now for fine-tuning the model to the copilot. And the prompting is very easy. It's very easy to use because it's free. It's a software. But it's not easy to write prompt. So you call it prompt engineer. And then it had a mid accuracy. It's not very high accuracy. That's why the general AI could not be direct to use the copilot. And then it's very cheap because it's a software. You don't need to retrain the model. And the data is privacy. But if you want to use the fine-tuning to the model, transfer the model to the copilot, you have 3 problems. You have 3 features that high accuracy. Fine-tuning model looks like retrain the model. It will be high accuracy. And it has more expensive because you need to retrain, you need more GPU, you need your server. So it's not cheap. And then it's no privacy because your data will be trained in the general AI together. It means that general AI, you get your privacy data. So that's the difference. Okay, let's see some general AI for self-driving. Looks like fusion, perception, and planning. And currently in China, self-driving is widely used for a lot of cars. But all the self-driving the system is modularized, just like the sensor, data from sensor, which will go into perception. It's like a computer vision system. It will then planning will give a decision on what to do next, and then control, steering, accelerate. So it's a long system, and which one has its module, but it's different to the general AI. Just like if the perception and planning will be fusion together. There will be an end-to-end fusion architecture. And the data will come in from sensor and direct sent to the fusion architecture and then output controller. So you can see the big model will be very, very important here. It will make decision. It will, instead of computer vision, it will instead of planning. So it's a complex system. So let me check how to do it, just like fusion architecture. It's just a research, not a production yet. But I hear that now Tesla, maybe this year, it will release a version for this one. But I think it may be a lot of problem. As a fusion architecture, it understands the scenarios better. Because you see that the system will be one big model. We can call it unified automotive driving. UNI AD algorithm framework. It's from a paper. The paper is get CVPR Best Paper 2023. And it gives us a very interesting opinion that the key point is perception and prediction could be together by this UNI AD framework. Okay, I want to read the details. And the second, it is plan-oriented philosophy. It means that everything could be planned. Every controller could be planned, originalized, and then will control the car. So anywhere, one word is that the system is from modular to one system together. So it's totally different. It will change the self-driving system. So let me see. Maybe this year or next year, the self-driving will become this architecture. So we know that general AI could affect cockpit and self-driving a lot. So we will choose one question. We will decide that general AI from cloud or from native. It's a very, very important question because just like ChatGPT, OpenAI, the AI is from cloud. It's cloud AI. You can get it from API, from website, and it has a lot of features that's public data. Because cloud AI is public, so it has a lot of knowledge. It's very, very big. It has super big parent. It's bigger than 100 billions. It has super power computation. 1 second, it could handle 1,000 tokens per second. It's very expensive. You have to pay for it, and high latency because it's internet. If you call it, you need to get answer from the internet, and not always on because sometimes when you're driving, you will get some place that have not internet. You will disconnect, so it's very dangerous. So native AI, it means that you put the general AI in the car. I think it's very, very important for the future smart car, AI car, because it has, in your car, you have personal data. It's privacy. You don't want your data upstream to the cloud AI. It's very important. So I want to keep my data in my car. It's very important, personal data. The second is small parent. And because your car didn't have enough memory, didn't have enough population, so you don't have to put a big general AI in your car. So it's 3 billion, 7 billion, 30 billion. And the lower computation, because 1 second, you could only handle 200 tokens or 30 tokens. And it's cheap and free. Yeah, because you don't need to pay for the website. You don't need to pay for ChatGPT. You can do it in your car. It's low latency, and it's real time. When you disconnect, you can get answer from the local AI. And it's always on. It's reliable. So you can see the native AI looks like more advantage to our car. It's privacy, it's personal, it's real time, always on, and cheap and free. So I think everyone gets answer. To my car, to our car, general AI, native AI is more important. So native AI, observability is better, but face big challenges. Yes, I gave some summary. They have 4 big challenges. The first one is performance problem. You see, the PP means that prompt processing, TG, text generation. The performance is very, very low compared to the cloud AI. So if you put 1 keywords, input the general AI, ask him to ask question, you need at least 5 seconds to output first token. So it's very slow. And the second is memory and bandwidth is not enough. Because for example, Llama 7 billion int 16 will cost 16 gigabits. And int 4 quantizing will cost 4 gigabits. It's a huge memory to your car because the whole memory in your car is maybe 24 or 32 memories. Maybe half of the memory will be used to run the general AI. The third is safety and security. It means that how to protect your model in your car, how to protect private data. And you need to help to ethics and prejudice problem. Just like you need to avoid that because sometimes if you output some not good picture, it will break the law. And third, the last one, resource queues. The customer first. It means that the LLM runtime will block the scheduler. For example, when the application is running, it means that it will get a lot of resource to run your car. So maybe your memory is not enough. It will cost OOM. So other application will be killed by the LLM. It's very dangerous. So I think new car operating system need to handle all of these problems. Otherwise, generative AI cannot be put in your car. Okay, let me see how to do it inside. First, how to optimize the performance and memory. Yeah, this picture is from inside. You see, because to the generation AI from one input and output, you can see it has two stages. One stage is prompting processing. This session means that he will understand your word. He will know what you meaning. It's very important. The second is the text generation. At this time, he will output token, give you answer. So you can see the first part, it looks like computation is very, very wrong, but memory load is not so critical. So it means that it's the computing, it's a computer bound period. So in this time, you need to do a lot. If you want to optimize the system, you need to use the computer bound swap memory. You can use CPU, GPU, NPU cooperation together to have a computation to make it faster. But in the second stage, you can see the memory bound is a memory bound stage. So yeah, you need to do a lot of things that like quantization, the model, compression, sparse, MOE. It means that all this technology will make the model smaller, make it sparse, and uniform memory to avoid the memory copying. So all this is the key technology to optimize the performance and memory. I can give some example. An activation, okay, because the activation is widely, you can get it knowledge widely in the website. The first one, activation, is use the flash to help the memory. And the paper is from Apple. The last year, December. I remember that. The paper means that LLM in a flash. Summary, the paper tells us that if you don't have enough memory to run model, you can use the flash to help it. Just like you need to swap some data from memory to flash. It's very, I think it's very useful, and we have tested. Yeah, it could work, but it has some disadvantage because it depends on the sparsity model, which is not used yet. Sparsity is not widely proved that it could work. So it will modify the model, maybe. So I think maybe next year, WWDC 2024, I don't think Apple will put this technology in his production because it has a lot of problems yet. It's a research. And the second activation is that it's still from a paper from Shanghai Jiao Tong University, yeah, the iPad's library. They use the sparse attention to accelerate the system. You can see the details, that's like the model. Here's the model input. You can see a lot of cube. Cube is something hot, red is hot, black is cold. So you can separate the cube. The hot cube is from the GPU to compute the hot, and use the CPU to compute the cold. So you can see, yeah, it could work, and it could make the computation lower and lower. So in this paper, it have a natural aware inference engine. It's a very interesting idea, and sure. So it has the performance. It will make the performance maybe 10 times faster. Okay. And activation 3, and use the lightweight runtime for native AI. And this is from the Llama CPP. Llama CPP is very, very famous recently, half years. And it have released several versions. Just like it make the model, 7 billion model, to a Llama CPP, and it could run direct on the platform, smart device platform. And by the GGML. GGML is the machine learning runtime. It could accelerate the model, and it has a lot of CPU, GPU cubes, and memory management here. So by this architecture, the model will be very lightweight and could be put direct in your smartphone, smart car, and smart PC. Yeah. And activation 4, and you can see the unified memory. Because we are not GPU, we have several unified memory for our smart device. So unified memory is very important because if you have unified memory, You don't need to copy data from CPU to GPU or from CPU to NPU. And so first, you have this architecture by hardware. The second, you need to have software to support this architecture. So SVA, Share Virtual Memory Address, yeah, this features is released in the OpenOLA 0.1 latest version. Yeah, it has released open source. And you can see that it has improved the memory efficiency and performance by the features. If you want to see the details, you can check the link. Okay, after that, everything is the performance. For the performance, make the generation AI run faster and faster in your smart car. And the second is that we think about security, protect the personal data. And the data, the content is from the WDTA. WTA is is a group, is the organization. It's an organization. It's mainly focused on how to make the model, how to make the general AI work and safety. So they have released a report, Generate AI Talent Development Framework. It have given some interesting ideas. I don't want to describe everything here, but I just want to say that the EU AI Act will release this year, maybe next month. And it will strengthen the use of data and privacy protection. So it means that, just like EDTA, it means that Europe will try to control the general AI data and tell us how to use it and how to control it. I think it's very important to global. And by this way, we can see that how to control the private data at the every state of the life cycle of the generative AI. Okay. The second, we're thinking of AI ethics and prejudice, because it's still like another paper. It means that filter bumble. Filter bumble means that if you want to get some answer from internet, you will always get the answer which you want. So it's not true, maybe. Maybe your answer will be modified by the Meta, by the Google. It's dangerous. So yeah, it's the result. So generative AI will have this same problem. If you ask question to generative AI, it always bring you something. Maybe it's not true. Maybe it's makeup. It's dangerous. So if you use an AI in your car, you will to understand that not every answer is correct. You need to avoid that, control it. So they are give some ways to control it. I don't want to describe details here. It has a lot of things here, but it has ways to do that. Okay, the last one is resource queues. It means that customer service first. For example, you can see that in your system, other app is always working. If you put a new LLM app in your system, the LLM app will waste a lot of memory, with a lot of NPU, CPU. It will affect your system. Maybe make your system panic, make your system OOM. It's dangerous. So who can control OOM? I think it's only the operating system. It will control two things. I think it's very important. It's scheduler. It will make sense that the front end application will always get the resource first. And the second, it need to control the memory bandwidth, control the memory usage by the MPAN. Yeah, this feature is very, very important in our smart car or in our smart device. By this way, we can make sure that the big model will not affect other application, and it could work directly and separately. So our vision is make sure the customer service first. Okay. Any more safety? And because we are talking about car, so car safety is very important to the car. And I don't want to say a lot of safety ideas here. Just we want to say that AI has come in. So AI changed the safety idea to the car. Here you can see, I direct give my results that we should have AI domain, because current car have two domains, cockpit domain and self-driving domain. And so if we want to put general AI in our car, we will have three domains. The third domain will be controlled by the hypervisor or kernel directly, because there's only hypervisor or kernel could control the heterogeneous computing, and here is memory, elastic, and separate. So the three domain is totally different. they have used the different computation, they have a different memory, they have different L, they have different priority. And of course, they have different operating system. So that's all. So yeah, we need to put AI domain here. And okay, this is our work recently half years. That's 50 more. Formal proof for Linux version field system. And recently, yes, we have released a paper to OSDI. Yeah, OSDI. This paper formally defined the locking order because we find that in our operating system, especially the VFS, there are a lot of bugs about VFS by the locking. The locking is very, very difficult to debug, to define, and to design. So we released a paper to tell the committer that how to design your locking, use your lock to protect your VFS. So it's a very, very long paper, and it's a talk about formally. So maybe you can check it by yourself. Yeah. Okay, I will give my proposal. After all, we think that the new software system for AI car is very important, and because it will have it will be more three domains and separately. I think it will have several key points. And yeah, the first one key point is that heterogeneous computing and unified memory architecture is very, very important to the general AI for the AI system. And the second is memory elastic and separation, because you need to make sure that the memory will not affect and the memory will be separate to make sure that self-driving will get its own memory, will not affect by the AI domain. And third, hypervisor for AI domain. Because in our car, we have already developed a hypervisor to separate the cockpit domain and self-driving domain. So we need three domains, and the third domain is AI domain. We need a hypervisor to do that. And four is the security is more complexity, because you till now you don't need, just as we said, you will get a lot of risk content. The general AI will output a lot of things. It's very dangerous. You need to control them, and the safety can be worse. And the lightweight inference framework and flexible schedule resource, customer service first. Okay, I think all this is very important for our new operating system, especially for the AI car. Summary, and which you can take that. The first, general AI and smart car. General AI is transforming the smart car. It's the future. Actually, it's the future. And the second, native AI has many advantages, but facing big challenges. We have discussion that. And the third is academic and industry collaboration for native AI, especially for innovation and development. Yeah, it's very, very important. We have innovation first, always innovation first. And four is learning from excellence. There are a lot of important activations, so we could share some knowledge. We will, together to make the general AI working for smart car. And the last one, operating system adaptation. Because we need to design new operating system, this operating system will be designed to be compatible with the dynamic and generative nature of the general AI. So it's totally different. So we need to adapt to new architecture, adapt to new scenarios. Okay, it's very important. Yeah. Any questions? Okay.
Memory accepted by other modules.
Okay. Do you need sound?
The unified memory have changed a lot. Like currently CUDA, the GPU has their own memory.
It's totally different. CUDA didn't have a unified memory. It's false. So yes, we know that Qualcomm chip has unified memory. High silicon chip has unified memory. Apple chip has unified memory. So it's totally different because CUDA used the PCIe to connect the server and the GPU together. PCIe is not unified memory right now. You need to because you need to move data from CPU to GPU directly. You need to avoid that. So in the Apple silicon, just like iPhone or MacBook, you don't need to move data from CPU to GPU. It's totally different. So I think Apple is that uniform memory. Okay. And anymore, and a lot of now the CUDA is still used in our car, actually. A lot of car companies use CUDA, yeah. But I think it's not, it has still a lot of problem. The CUDA memory is not enough. HBM is not enough for the car, actually.
Okay, thank you.
Do you think memory bandwidth is important?
Yeah.
Or
Actually, very, very important.
very important.
Yeah.
So the current memory, like DDR5, DDR4, is not enough?
Of course, yes. Because in our computer center or data center, memory used HBM. HBM has a very, very high bandwidth, but in device, we could not use the HBM. So we could only use the LPDDR5. LPDDR5 has 100 gigabits per second bandwidth. So I think it still works. So the general AI is very, very slow. The talking is very slow. It's a very important problem. Okay, lunchtime.
Thank you. It's very good.